Hi everyone. This is Sainath and my teammate is Gautami. So, today we are going to explain about a game called Game of Life. We designed this game using the JavaScript, CSS, and HTML. Okay. So, the project description. Let me explain what the game is, how the game is designed, or let's say, basically, this game will have infinite two-dimensional orthogonal grid square cells where each cell has two possible states, either live or dead, or we can either also call it as a populated or unpopulated. And every cell interacts with eight other neighbors, and the interaction could be either horizontal, vertical, or diagonal. So basically, the user interacts with the game of life by creating an initial configuration and observes how it evolves. So let me discuss about the rules for this game. So let's say if a cell has two or three living cells, then it is called a live cell. So again, let's say there's one cell, and if it has two cells which are live, then it is called a live cell. And if it has three cells which are live, it is called live cell. So basically, a cell should have at least a minimum of two cells and a maximum of three cells to be in order to be a live cell. So if a cell has more than three live cells, then it is called overcrowding and the cell dies. If a cell has less than two neighboring live cells, then it is called underpopulation and the cell dies. And the cell comes to life again if it has exactly three neighbors, and the cell dies if it has less than two, less than or two or greater than three neighbors. So this is a basic theory behind the game. These are the basic rules, and these simple rules will create an interesting game. And so let's see, these are the patterns which we implemented using JavaScript. So the first pattern we call it as a still life. The second one is oscillator one. The third one is oscillator two, and the glider and the spaceship. These are different patterns which we implemented here. And let's go to the next slide. I'll show you how these patterns look like. So these are the examples of different patterns here. So the still life has these patterns. So block, beehive, loaf, boat, tub. These are the different patterns available in still life. Oscillator has these patterns: blinker, Todd, bacon, pulsar, penta, decathlon. These are the different types of patterns in oscillators, and we have implemented two of these patterns. And these are the different patterns in a spaceships: the glider, lightweight spaceship, middleweight spaceships, heavyweight spaceships. These are different patterns available for spaceship patterns. So now let me explain how the game flow works. So this is a UML diagram of our project. Hmm. So yeah, the user will start the project by selecting the size of the grid. So the grid size can be anywhere between 120 cells to 150. And when the user gives the number, the grid will be generated, and user initializes the living cell coordinates, and he'll start playing the game. So once he clicks start, the simulation will begin, and our algorithm will check for if the next cell is a live cell or not, or if any cells are remaining. So if there are any cells remaining, then it will check if a current cell is live cell, and if it is yes, then it will check if there are any three adjacent living cells. If yes, then it will say the cell is alive and it will print the generation. If it's no, it will kill the cell. And here, if current cell living, if this condition fails, then it will check for adjacent cells. If there are two or three adjacent living cells, then it will create a live cell, else it creates a dead cell and it will print the generation. So this is a basic UML diagram and this is a flow of our project. So yeah, this is about the UML diagram. And if we go to the next slide, this is how the main page of our game looks like. So we have few different buttons over here, the start, stop button, step count, step button, step 23, which means the user can directly jump to the 23rd step of the game. And these are different patterns that are over here. So let's go to the next slide. So yeah, the user will so initially the user will enter the grid size, enter number of cells that he wants to be in each row or column. So that will generate an n by n grid. So once the grid is generated, now user can choose which pattern he wants to play with. So once he chooses the pattern and selects start, the game will begin, and by increasing the step counter, the game will proceed to the further levels. So this is this one is a random. This is an example of a random pattern that is being generated. So this is example for 23rd increment. Yeah, and when it comes to testing, we use the extends class. Uh, It's a JavaScript validator, and we tested our code using it. And we also used W3C markup validation services and W3C CSS validation services to validate our code, and everything is working perfectly. Mm, yeah, I think that's it. So now my teammate Gautami will show you a small demo of a game, like how it's working and how the feel of the game. You can go ahead, Gautam.
Yeah, let me show you the main page of the game, how it works and all. So as it has mentioned here, we can choose any number between 20 and 150 so that it will generate. Suppose I selected 20, and when I click on start the game, a 20 by 20 grid is being generated here. And when I click on start, immediately you can see the count getting increased at the generation tab. And whenever I want to stop that count, I can immediately click on stop. And so if I click on the still life, you can see that the current living cell population is 4. So a random set of 4 cells is being selected. So here we have 4 patterns as we have discussed previously. So when I click on random, there is no specific pattern. Uh, Random patterns are being generated here. So like I can click step, by which as it is random process, the step count will also be in a random manner. And coming to the 4 patterns, the first one is oscillator one. Uh, so oscillator one initially took a pattern like this at starting of these cells. So when I click on the step, the next step, like if you see, as the surrounding 3 cells are living ones, so that cell also became living one. So yeah, in this way it goes on. And when I click on the oscillator 2, there's a pattern being generated here, and you can check every step by step process how it goes. So when I click on the step 23, so it directly switches to the 23rd step and it displays what it happens at the particular pattern at 23rd step. So the glider helps in the movement, like if you see, if you click on the every step, then it shows a movement based on the rules that we have discussed before. So similarly, spaceship also works, and you can check by clicking on the step and as well as step 23. And that's it from our end. Thank you.
So thank you, Gautami. So thanks everyone. This is a demo of our project, Game of Life, which we did using JavaScript, CSS, and HTML. So yeah, thanks everyone. Have a great